Hello everyone, this is Shahinur Rahman Laskar from the Department of Computer Science and Engineering, National Institute of Technology, Silchar, Assam, India. Today I am going to present zero-shot neural machine translation on Russian Hindi @LORES MT 2020. So these are the contents which I am going to cover. First I will discuss about introduction, then related work, then about data statistics, then I will discuss our system description, then result and analysis, and then finally conclusion of our. Neural machine translation is a widely accepted technique in machine translation community where one source natural language is translated to another target natural language. And it shows a remarkable performance in both high and low resource language pairs, but it needs sufficient training corpus. So the availability of parallel corpus in low resource language pairs is one of the major issue in machine translation. To mitigate this issue, NMT attempts to utilize monolingual corpus to get better translation for low resource language pairs. Workshop on technology for MT of low resource languages, also known as LORES MT 2020, organized shared task of low resource language pair translation using zero-shot NMT. Here the constraint is we cannot use parallel corpus, only monolingual corpus we can use. So we have participated in this task on the Russian Hindi pair, and our team name is CNLP NEEDS. We have used mask sequence to sequence pre-training for language generation, also known as MAS, with only monolingual corpus following unsupervised NMT. Now coming to related work, so there is a lack of background work on this Russian Hindi translation pair. However, literature survey finds some related work on other low resource pair using MAS, and they achieved blue score 37.50 and 34.90 on English to French and French to English translation, and also for English to German and German to English it attains 28.30, 35.20. So this is the dataset statistics. This dataset is provided by the organizer, where these are the these are the statistics of Hindi and Russian sentences of training, validation and test data. We have used this. Now coming to system description, we have adopted MAS based unsupervised NLP to build our system on a single GPU. So our system consists of two major steps. One is pre-training and other one is fine-tuning. We have used default settings of paper number 1. For BP and vocabulary creation, we have used cross-lingual model XLM, code base, and we have used Moses for tokenization purpose. We have used first BP to learn byte pair encoding vocabulary with 50,000 codes, and due to limited computational resources we have used 256 embedded layers with base size 32, token per batch 500 and dropout 0.1. So these are the results which is declared by the organizer. So we have here the with extension C is the with using external monodata, and system with extension A is the without using external monodata. So in external monodata we have used the IIT Bombay monolingual corpus, and also we have used for Russian monodata from WMT 16. Now coming to result and analysis. So these are the example sentences of translations. So here we have noticed that our predictor translations are is not good in case of adequacy factor of translation. but it is better in fluency factor of translations. Now conclusion and future work. This paper presents a zero-shot and empty task on the Russian Hindi pair, which is participated in Laura's MT 2020 shared task. We have used unsupervised NMT approach of mass to build a model for both direction, Russian to Hindi and Hindi to Russian. And our obtained score and closely observed predicted translations pointed out that in future work we need to improve our model for better translation accuracy, and we will try to incorporate multilingual approach to improve the translation accuracy. Then I would like to thank Center for Natural Language Processing and Department of Computer Science and Engineering at NIT Silchar, India, for providing requisite support and infrastructure to execute this work. And also we would like to thank Laura Smith MT 2020 shared task organizers to organize this competition. These are the reference. Thank you.